All right, if you are done, feel free to pass it over towards the middle. I'll come get your quiz. If you're still working, you can wrap it up, I'm sure, in the next minute or two. Is this all set? All right, very nice. Good job. Excellent. Thank you so much. Well done. Wow, good job. Nice stack here. Well done. Good job. Thank you. Nurse, over. All set. All right, you're doing it. I'll give you another minute. Don't worry. I'll go do attendance while I'm waiting here. Let's see. Statistics. Everyone is here, right? Good job. All right, submit. All right. I'm ready for you. And you're ready for me, right?
Yes.
Yes, you are. You were just double checking. Very good. Nice work. Okay, so let's take a look at this. Super easy, hopefully. First one, you're given the margin of error and the point estimate, and you're supposed to come up with the upper and lower confidence limits. So that's easy enough. You're just going to do, oops, got the wrong implement. So 0.31, whoa, that's weird. Minus 0.06 is 0.25, and then 0.31 plus 0.06 is 37, right? Is that right? 3725? Okay, so you might have written it like this. Just put the smaller number first. If you put the bigger number first, it looks dumb. It does. Just trust me on this. And then this one, so we have this thing, and we're supposed to find the mean. The mean will be the middle number, so you're averaging those two things together. What's that going to be? 34 divided by 2, so 17. 17 is the middle of this. And then the margin of error is just the distance between that and either of the endpoints. And so I'm going to go with the top 5.25, I believe, is the difference between 22.25 and 17. Does that look good? So that's that. Now, what we're doing today is we're going to be taking actual data and figuring out how to compute these numbers. So that's our job today. We're going to use Excel in a bit. If you want to get it all booted up and ready to go, you can go ahead and do that. Let's see, where is my, there it is. So this is what we're heading for. So if you are, so we'll get to this in a minute, but just so you know, oh wait, do I have, oh no, I don't. Okay, I thought I had, I don't have any, oh, I know, yeah. So if you don't have this downloaded to your computer yet already, there's the anonymized data from you. So this is from the survey that I did at the beginning of class, if you remember. And it's at the bottom. It says for Wednesday, January 22nd. We used it back then, but we're going to use it again today just to construct some confidence intervals for those data. So anyway, that's what we're going to be using. It's on the Moodle page under Excel, classwork Excel files, and you don't see most of them. You just see there's only a few there that you see. So, and I guess this gives you a hint that there are M&Ms in your future. So, but not, it's gonna be a little while, Easter. Okay, so a couple, oh, it's not showing up. So before we get to Excel, I need to explain a couple of things. And the first thing is that when we go back here, let's see, there it is. When we construct confidence intervals, the way that we do it is going to look very similar for both of these, but there are some differences that we need to make note of. And so notice that, get this crammed on here. So notice that here, when we're doing a mean, what we're doing is we're doing a confidence interval for quantitative data. Sorry, I don't have my little podium here, so it's going to be harder to write. So quantitative. Yeah, I took it down there because I want to make sure you can see the screen when we get to Excel. So quantitative data. quantitative data, you're going to use the confidence interval for a mean. And when you do this, you're going to use a distribution called the t-distribution. I'll explain this in just a minute. It's got an interesting story behind it. If you're doing a proportion, this is qualitative data, and there you use the normal distribution. So that's the first note, the difference. So, so when we're doing means, we use this so-called t-distribution, and when we use the proportions, we're going to do the normal distribution. By the way, if you've forgotten, qualitative means categories, right? Categories like male, female, your color of your hair, color of your eyes, whatever it is, the type of animal that you have as your pet, if you have a pet. So that's categories. Means, these are numbers like how tall are you, what did you get for your last test, those sorts of things. So scores, numbers. Now, as far as the t-distribution goes, let me tell you this story first, and I hope this is okay. I haven't gotten in trouble yet for telling this story. Anyway, there was a researcher that worked for Guinness Brewing Company back in the 1800s, late 1800s, and he was tasked with making the beer better. This is in Ireland, Guinness Brewing Company. They were trying to make their beer better, and so he was taking statistics based on the beer and based on the stuff that was going into the beer. The problem was that he had to deal with very small sample sizes. He had sample sizes that were much smaller than would warrant using a normal distribution for a variety of reasons. And so in the process of trying to figure out the statistics, he found that he was always off by a little bit. He was off by a little bit in his calculations. And so what he did was he invented a new distribution called the t-distribution. And this t-distribution, it was adaptable, and it sort of, let's see, do I have room to do this? Oh, I do, it's right here. I even made myself a little bit of space. So the normal distribution looks something like this. So that you're familiar with, this nice bell-shaped curve. The t-distribution looks something like this. Let's see if I can do this right. I always have trouble. I should just have this. There. And you might look at that and say, well, hey, those look a lot alike, and they sure do. The deal was that what this guy figured out was that, you know, when you're dealing with smaller sample sizes, it turns out that the normal distribution doesn't account for the fact that you have some error that creeps into your data because there's such a small sample. And so because of that, if you use this slightly different, almost the same, they look very similar, but almost the same distribution, but very slightly different distribution that's a little bit shorter and a little fatter. And you might say, well, isn't that just another normal distribution? And the answer is it isn't quite. So the curves, there's some mathematical differences, and those subtleties are not important to you. Just be aware that there is it's a different formula for these two curves. And not only that, but this curve, the red one, has some parameters that allow it to be adapted to whatever sample size. So if you have a small sample size, I'll show you, small sample size, like very small, then that distribution might look something like this. So maybe you're seeing what's going on here is that the smaller the sample size, the shorter and fatter this curve is. But they have this property where they all sort of intersect at a certain point. But so you have a shorter, fatter distribution. And then if you have a larger sample size, it ends up being taller. And the closer you are, the bigger your sample size, the closer you'll be to the actual normal distribution. So that's the story behind this. And this guy, he hadn't signed an NDA. I don't think those things existed back then, but he was worried about his job. And so when he went, he wanted to publish this. And so he said, you know, I've got to publish this to let the statistical community know about this beautiful distribution. And so when he published this, he published it under a pseudonym. And the pseudonym he used was Student. And so because of that, this distribution is now known as Students, with a capital S, Students t-distribution. because he didn't want his bosses to say, you're giving away trade secrets, but he knew how important this was. And this distribution now is used, and I actually have looked up his name before, and I've memorized it, and then I've forgotten it. I can't remember the guy's name, but I can remember his pseudonym, student's t-distribution. So that's the distribution that we use for the confidence interval for a mean. It's all built into Excel, so you don't have to worry about the formula or anything. Here's some properties. It's bell-shaped. It looks like a normal distribution. The mean, median, and mode are all located at the center, just like a normal distribution. The variance is a little bit bigger than 1 for the standard t-distribution, so it's kind of squished out at the sides. The degrees of freedom, that's the thing that's going to be tricky. It's related to the sample size. So degrees of freedom, that's what kind of controls how tall or small your curve is. So we'll talk about degrees of freedom momentarily. Larger sample sizes will give you a t-distribution that is very similar to the normal distribution. So that's the deal there. So let's get to how we're going to do this. And you'll notice that some of this is somewhat pixelated, like this, and you'll see this on the next slide as well. And the reason why I did this was I wanted to have this as similar as possible to what Newton was going to have you do, so that when we build our little spreadsheet, it'll be as similar to what Newton suggests you do. So there are a couple of places that later on this semester that I diverge from what Newton does. But for us, we're gonna stick with Newton, at least for now. So here's the idea, is to make and that's weird language there. Let me back up and deal with this here. Give me a sec. So let's say that we want to make a normal not a normal distribution, a confidence interval around a particular average. So we're going to look at some averages here in a minute, but we have an average and we want to make a confidence interval around it. We're going to use the student's t-distribution, which looks very much like a normal distribution. And the way we're going to build this confidence interval is we're going to use that to put together, say, 95%. We'll pick a number. Usually it'll be 95% or 99%. And then we're going to build this interval, and we're going to end up saying that we're 95% confident that the truth is within this interval. So we're kind of turning the whole central limit theorem upside down when we do this, but it all works mathematically, so don't fret. So this is our goal, is to say, okay, I have this interval, 95% of the time the truth will be in there, 5% of the time it will be outside there. So when we say 95%, sometimes we're going to be referring to alpha, and alpha is the opposite. That's how uncertain we are. So we're 95% confident that the truth is here, but that means that there's a 5% chance that we're wrong. So whenever we use alpha in here, and this is for the rest of the semester, alpha is going to refer to sort of what our chances are of being wrong about whatever conclusion we have. So that's what alpha is. So anyway, getting back to this, that sort of weird language up there, 100 times 1 minus alpha %, all that is saying is it's just a way of saying that if alpha is 0.01, then you're dealing with a 99% confidence interval. I think you can do this math in your head. It's just a weird way of saying it. So once again, I'm just trying to align myself with Newton as closely as possible. So getting back to this, you have some information here that is, the sample mean. We're going to get this really quickly here. Just give me a sec. We have the, let's see, this critical value. What that refers to is if this were the t-distribution, the critical value is how far you have to go in terms of standard deviations to get to the edge of this confidence interval. So we'll get to that in a minute. It's kind of like back in normal distribution land, the empirical rule said 2 standard deviations gives you 95% approximately. It's a similar deal here. So with the student's t-distribution, it'll be 2.1, or so. It won't be exactly 2. standard deviations out. So that's what that thing is. S is the sample standard deviation, so we're going to have to compute that. N is the sample size. We'll have to deal with that. So here's what this looks like. By the way, here, that should be somewhat familiar. That is the standard deviation of the sampling distribution using the central limit theorem. You remember how you took the old standard deviation, divided by the square root of n, and you got the new standard deviation? And so essentially you just have your middle minus and plus this number of standard deviations. That's all this is. That's what all confidence intervals are. And when we get to the proportions, which hopefully we will, if I don't blab too much, then we'll be okay. So here's what we need to do is, so if you have downloaded, let me get this here, Statistics Survey Anonymized, we will use this. Let's see, can I do this? I think I can. Yeah, that doesn't look good. Just a minute. I'll just leave it like this for now. Okay, so we'll just have to toggle back and forth. Give me a sec. So I'm going to ask you to do a couple of things. First off, we have the data. The data is right here, and so I guess I've got mine. I don't know what yours probably opens up to MLK or something. Whichever one, doesn't matter. I guess we could start with ages. So we'll go back to the age tab, the age tab, and so bear with me as I toggle back and forth. It says that we need several things. We need the sample mean, the sample standard deviation. So here I'll highlight these. These are the things that I'm going to compute right now: sample mean, sample standard deviation, and sample size. So let's go ahead and do that on this sheet. Okay, so this is going to be the mean is going to equal average of A colon A. You could actually highlight the actual numbers if you want, but this is kind of the cheater way of doing this. The only problem with doing it this way is notice that the entire, if I do average of A colon A, it means average everything together that's in column A. And so if there's anything down, like, wait, where is this? Here we go. So if there's anything like down here, hidden from you, like if you have a number way down at the bottom of column A, it's going to mess up your average. So it might be safer to just say equals average of, and then highlight the numbers. Whoop, come on, there we go. So that's another way to do it, is just highlight those numbers. You get the same answer. But I oftentimes, if I know that there's nothing down there, this is just a quick way to do it. So little hint. So we'll do the standard deviation. Standard deviation is going to equal STDEV dot S. So you know how to do this. This shouldn't be too much of a shocker. And I'm going to be lazy and just do A colon A. I need the sample size. And to get that, I'm going to use the count function. And what that does is it counts all the numbers in column A. You might say, well, wait, what about that word age? Don't worry, it's not going to be counted. Notice that this goes up to 27. It didn't count the age. There are 26. So there's some things that we'll do to begin. So we've got our stuff from here. I know I'm going a little bit quick, but don't worry, I'll slow down when it is important. So now it's going to be important that you do exactly what I do. And as always, if you get stuck when we're doing Excel, please let me know. Don't let me go on ahead and come to me at the end and say, I didn't get it at the, long time ago. So what I just did was I opened up a new Excel spreadsheet. So you're going to want to make a new Excel spreadsheet. And the reason why is because this new Excel spreadsheet, you're going to save it somewhere where you know where it is. So I'm going to stick it in my spring 2025 folder. And I'm going to call this confidence interval. Let me put an underscore. Interval gold. I think I mentioned yesterday that we're going to be making a spreadsheet where that is going to be like gold, and you don't want to lose this. Here, I can zoom in so you can see there it is. Oh, it's really pixelated up there. But anyway, I named it confidence interval gold, and I know where it is. So you want to do the same thing. You want a blank spreadsheet, and you want it to be somewhere where you know where you can find it so that you can use it when you do your homework and when you do your projects. So make sure you know where this is. So if it's on OneDrive, make sure you know where it is. Okay, so next thing I'm going to do with this is at the bottom, you'll notice the tab is called Sheet 1. I don't like Sheet 1. I'm going to rename that tab. So right click or double click or whatever you Mac people do, and I'm going to select rename, and then I'm going to rename this as mean, whatever. So once you have that, I'm going to make a new tab and then rename that tab and call that proportions. So as you can guess, we're going to have two tabs. One of them will be means proportions. There, good enough. One will be your means, one will be your proportions, so that when you go to do your homework, if you're supposed to do something with a mean, go to the means tab. If you're supposed to do something with proportions, go to the proportion tab. This is going to be beautiful. If you can keep your hands on this, if you lose it, it's like gold. You're going to have to borrow from a friend. But your friends will help you, won't they? So if you get stuck or if you lose your spreadsheet for some reason. Okay, so next, we're going to build this thing like this. We have X bar at the top, and then we have S, and if you need to like label it as standard deviation, that's fine, and then N. So let's just go back. In fact, here's what I'll do is I'll just pull this over so that we can see both of these. There they are. Okay. I know there's a temptation to copy and paste, but that's dangerous when you have formulas that you're copying and pasting. It's possible to do it correctly, but I'm not going to mess with that right now. I'm just going to type this in, 19.3077, 1.56893. If you have more digits than me, I don't care. And then 26. So there's my three numbers there. Okay, so next we're going to have the, let's see, I'm going to make sure I do this exactly the way that I did it, that your thing is here. Okay, so this one is this one's the boring one, sadly. Okay, we'll do it. Okay, so this is going to be confidence. Oh, no, let's do this. So go over here, we'll label it in a minute. So this is equal to confidence, because we're doing a confidence interval dot t, because this is a t distribution, confidence t, and then alpha. Oh, I forgot alpha. Just a minute. I have to stop and put alpha in here. Alpha. Sorry about that. So alpha, how confident do we want to be? Do we want a 95% confidence interval? Do we want a 99% confidence interval? Let's do a 95% confidence interval. That will mean that alpha is 0.05. So you can pick your alpha level based on whatever the problem says in Newton or on the project. Okay, now that we've got alpha, sorry about that. Now we'll do the confidence. Equals confidence dot t, open parenthesis, and then we need the alpha level, so go up and click the 0.05. And then we need the standard deviation, which is right up there. And then finally, you need the sample size, which is over here. So click that. So this is what this should look like. And what this is going to do is it will take all of that stuff and put it together and compute the margin of error. So this is what you should have typed in. And that all together is the margin of error. So I know I went through all the rigmarole of showing you this formula, but don't fret. That formula is going to be important when we do the proportions. So it turns out that the means are actually a little bit easier than proportions because there is this built-in function that for Excel. Okay, now that we have that, we can come up with our lower confidence limit, and upper confidence limit. I know so many acronyms. If you need to, you can type it out. Lower confidence limit. There it is. That's what LCL means. And UCL is upper confidence limit. But anyway, getting back here, the lower confidence limit is the mean minus the margin of error. And then the upper confidence limit is the mean plus the margin of error. And that's it. So there we go. So here I can show you these, but I think it's pretty straightforward. I'll pause, make sure everyone's at the same place. If you're stuck, or if you're just confused, or if you are stuck somewhere, let me know. Yeah, what do you think, Will? So that was this, okay, so that one I copied from here. And the way I got it was I just computed the standard deviation of the data that I had. So in general, I think, I can't remember what Newton does. Sometimes they give you some data and you get to compute the standard deviation. And sometimes they give you the standard deviation and then you just run with it. Anything else that we need to deal with? All right, we're almost done with this. And then we get to move on to a couple examples and then go on to the proportions. Excellent. Okay, so let's finish this up. Let's see, where should I put this? Okay, so if I were doing this, so just so you know, if I were doing this for a project, which you'll do projects for me, well, at least one with confidence intervals, what I would do at this point is I've got my confidence interval gold over here. This is like gold, don't mess with it, leave it alone. But if you need to, you can always copy this stuff. So just copy that whole block of stuff and stick it over here in the spreadsheet. And that gives me, there it is. So this is in the, what is this, age? Okay, yeah, this is the age stuff. So there's all my numbers, but that's not the final answer. For me, even though you don't, well, you kind of have to do this in Newton, but you don't have to do it quite as, it's not as hard as what I'm going to make you do. So what I'm going to make you do on quizzes and tests is not just tell me about these numbers, but also write a plain English sentence. But fortunately for you, I have a template for you. So here is the template. What you're going to write, I'll write it out here, then I will type it so that you have plenty of time to digest this. I am blank % confident. So you're going to start your sentence with that, and the thing you put in the blank is your confidence level. I am blank % confident that the true, big blank here, I'll explain, is between blank and blank. Okay, so this, let me put in red. This is the confidence level. Confidence level. So that's easy enough, you know, 95%, 99%. Now this, that thing, that is, let's see, plain English description of the parameter. Parameter. I know, all these fancy words. What are we measuring? What is it that we're interested in? Tell me in plain English. So don't just give me some symbols. I'll show you this in just a minute. And then these two numbers, this is going to be the lower confidence limit and the upper confidence limit. And once again, please, please, I beg you, put the smaller number first. It looks stupid when you put the big number first. It does. You can try it and you'll find out that it does look dumb. So don't do it. Okay, so let's see if I can do this. Okay, so there it is. That's the template that we'll use for all of our confidence intervals. Now let's actually type this. Give me a sec. Where is it? Here it is. Okay, I'll type it in. So I am 95% confident that the true mean, okay, so here's the blank that I'm about to fill in. So what is it that we're measuring here? We're measuring the age of MVNU students, and we computed a mean. So just think about what is it that you measured and what is it that you're actually computing. I've computed a mean of ages. So the true mean age of MVNU students is between 18.6, let's just go with that, and 19.94, period. So let's see, can I, oh, here, just a minute. Let me do this so that you can see it. There's these little tricks. We're going to wrap. Oh, no. Merge. Oh, no. Can I undo? Oh, come on. What happened? Sorry, I did that in the wrong order. Okay, merge, then wrap, and then do that. Okay, that's better. And then let's see, can I, true mean age, just a minute. The true, that is, oh, good. Yeah, I can make it red. Okay, so that is this blank here. So the plain English description of the parameter, what is it that you're measuring? Tell me what it is. Don't give me a bunch of symbols. Tell me what you're measuring. I'm measuring the mean age of MVNU students. You can do this. Okay, let's do this again with the next. Let's see, do we have another one? Siblings, pets. What is pets? Oh, number of pets. Taylor Swift? I don't know. Let's do siblings. Okay, so, well, let me back up here. So are there any questions, concerns, fears, worries? Because let's see, we've got 20 minutes. We can do this. Okay, so let's blow through one more example, and then we got to get on to the proportions. So yeah, let's do the siblings. Siblings, how many siblings do you have? So you know the drill. Before I use this spreadsheet, so there's my, oh, let me doctor this up one more time. Let's see, I've saved it. I have saved it. Good morning. Yes, I've saved it. Okay, I wanted to do one more thing, and that is this. You can do this if you want to. This is optional. I like to, and if you're colorblind, then this is not going to be as effective, or you can figure out how to do it. But I like to highlight those and make them green, which means go ahead, change those numbers for whatever problem you're doing. Down here, I usually put those like red, because those I don't want you to mess with. So just to sort of caution against, I'll just make those like red text or whatever. So you go ahead, change those numbers up there, because that's going to depend on whatever problem you're working on. And then save this, keep it. Okay, so let's go ahead and do this one. And let's say that we want a 99% confidence interval. So 99% confidence interval is what we're going to do. That's CI. It looks like CL, but it's a CI. Okay, so let's do this again. We have the mean, we have the standard deviation, we have N that we're going to compute. And of course, 99% means alpha is 1%. So let's do this. Mean is average of, whoops, A colon A. Whoops, there it is. This is going to equal the standard deviation dot S, because this is a sample. A colon A. N is equal to the count. I think it'll be the same count as before. And we should have those as our, that's what we're going to plug in to the our confidence interval gold. So I'll just pause. I know that was super quick, but I think that's probably not a big issue, is getting those numbers. And even if you can't figure out how to get these numbers, you can just copy those numbers into your confidence interval spreadsheet to make sure it's working. So this is just to make sure everything's working. So we have a 99% confidence interval, which means that this will be 0.01. Then up here, X bar is now 2.153846. And then S is 1.592289. And there it is, done. See why I call this gold? It's because that's the answer. There's nothing more to do. It's done the calculations for you. You're all set. So we have this. And so let's just type my, just a minute. Try again. Let's type the answer in. Where is it? It's this one here. Okay. So here's my answer is I am 99% confident that the true mean number of siblings that MVNU students have is between, 1.3, let's just round to one digit, and 3.0, period. So here again, you can see that I've got the same format for my confidence interval. I am confident level. And then this line is the thing that I'm measuring, the true mean number of siblings that MVNU students have. That's what I actually measured. And then there's my lower and upper confidence limit. And if you want to, you can experiment to see how dumb it looks to put the 3 first, but I'm not going to do it. So you can do it if you want to, and you'll say, wait, that doesn't look right. Well, I hope it doesn't look right to you. Okay, so there it is. I'm all done. Any concerns, questions about this one? Because we do need to move on to the proportions. That's pretty straightforward. Yeah, I mean, once you have it, then it's straightforward. Okay, so let's go on to proportions. So how to do a proportion. So here again, I've copied and pasted the stuff from Newton because I like the way they do it, and I'm happy to just use their suggestions. So this is a little bit more involved, but mainly because there isn't this beautiful built-in function. So back here, you had this confidence.t. You don't have that with the proportion. So this is going to take a little bit more effort, but not too much more. So let's say I want to compute a confidence interval for proportions. Then what we're going to do is I have some spreadsheets here. We're going to start off, I guess, this is the way Newton suggests you do it. You start off with your alpha level, which is 1 minus the confidence level. So why don't we just follow the instructions here? So what I would suggest you do is, let's see, get rid of that. Can I get rid of it? Yeah, get rid of that. Yeah, I'll just slide this over a bit. So in Excel, go to your proportions tab. This should be blank. And we're going to basically just copy this down. Don't worry about having, you could go and change your font to the symbol font if you really want to and get alpha there. But I'm happy to just type the word alpha and then X and in and then P with a hat. Here again, I know it looks like fat, but that thing, you can get that if you really want to. I don't care. So I'm just going to do it like this. So, by the way you would do this is you'd have to go up into insert, you insert an equation, and then you can tell it, take a P, and yeah, it's not worth it. Really not worth it. Okay, so here's how this is going to work. Let's use the numbers they have, and then we can talk about how we might change it. So the alpha level is always 1 minus the confidence level. Apparently, they're interested in a 90% confidence level, which means 0.1 is alpha. X is the number of successes, the number of yeses, the number who said that they like cats more than dogs, or whatever it is that you're studying. So that's what X is. And then N is the sample size. So maybe I should even label this, but I think you know what N is. Sample size, 1,000 for this particular situation. This one, though, might require us to just say this is the number of successes. No. Let's just leave it as X. I think you can figure it out. Okay, so P hat. P hat is the proportion in the sample. And they even give you a little hint there. So this is going to equal this divided by this. So that's easy enough. It's 0.05. So 5% of the sample said that they like cats more than dogs, or whatever it is that they were studying. I don't know what it is. I'll have an example here that we'll do in just a minute. So now things get a little bit more complicated because what we have to do is we have to plug in the formula for the actual, like this is the harder version because it's not a built-in formula, but it's not terrible. It's not terrible. So the next step is to compute the Z star. This is similar to T star that I mentioned. It's how many standard deviations we have to go. And so we'll go over here and call this Z star. Good enough. And so this is equal to norm.s.inv of 1 minus the alpha level over 2. I know that looks really complicated, but it's not that bad. You're not going to be able to see what I'm drawing. I'll show you in just a minute. So let's see. Here we have this. Okay, just to show you what this refers to, if you have a normal curve, let's say that there is a 90%, that's what this, the 0.1 alpha level would be a 90% confidence interval. So you want 90% to be in this bulge in the middle. So how much is on either side is the question. Well, 5% is over here, 5% is over here. But then you have to remember that Excel is leftist. And so if I want to know where these marks are, I'm going to need to compute the inverse of this. So this, oh no, it's 5%. So this will be 95% or 100% minus 5%. So to figure out where this mark is, you just use that. So that's where all the formula came from. I know most of you probably don't care. There it is. If you get this, and there's your number, it's 1.645 or 1.64485, then you're in good shape. And if you adjust alpha, this will adjust as well. For example, if you want to be a 95%, let's just do this really quick, 95% confidence interval, you know from the empirical rule that that's about 2 standard deviations on either side. Well, check it out. 95% confidence interval has an alpha of 0.05, and check it out, 1.96, almost exactly 2 standard deviations, just as you would expect from the empirical rule. So let's go back to 0.1. Kind of makes it a little tighter. So that's our next step. Now let's see if I got this all set up. There we go. So now this is the hard one. So, and each day that we do Excel, you're going to find that there's going to be something challenging that you have to type in. Just make sure you do it. If you don't get the same number as me, it's okay. We'll figure it out together. So this is called the standard error. It's like the standard deviation, except for what is it called? Sampling distributions. So this is the standard error. So it's like a standard deviation. That's it. So, so for this, this is going to equal the p hat. Whoops. No, I square root. Let's get rid of that. Square root of p hat times, in parentheses, 1 minus p hat. And I don't know if you recognize that formula. That's the formula we used when we were doing the binomial distribution stuff. This is the standard deviation of the binomial distribution. But then we're going to divide by n. So right there, I divide by the sample size and then close my parentheses for the square root. So it's very similar to what we did with the means. You take the standard deviation, which in this case is this nasty formula, divide it by the square root of n, but notice I can just put that n right inside the square root because of algebra. And you should get this number, 0.00689. We're almost done. I don't even know if I need to. Do I need to? Yeah, I guess I do. Well, I'll show you this next slide, and then I'll just go from there. So the next one, margin of error, is just going to be, I'll just call it MOE. That's just going to be equal to the Z star times this standard error. So, you know, you can think of this is how many standard deviations you have to go on either side to get your confidence interval. And here is the standard deviation. So this is how many standard deviations. This is the standard deviation. Multiply them together, and you get the margin of error. And now you can do the rest yourselves. It's not hard. Lower confidence limit, LCL. Whoops, let me capitalize that. LCL, come on. And then UCL, I'll just do it like that. Okay, so the LCL, I guess we need to know what's in the middle. The middle is the p hat. P hat is the proportion from the sample. So this will equal the proportion from the sample minus the margin of error, and then this will be the proportion from the sample plus the margin of error. And that's it. So there they are. So not too bad. let me highlight some things and then we'll do an example and then I think we'll maybe be done. Oh, yeah. Yeah, sorry. Thank you. If you do have trouble, you can tell me what to click on and I will click away. I'm happy to click. So, does that look all right? You're still not working? Okay. I can come look at it in a sec. Hayden, you had something you wanted to look at? It is rounding. Don't worry. Yes, Elizabeth. The what? Oh, here, just a sec. Just a minute. So the margin of error is, yeah, no, it's fine. It's just this times this. So it's kind of, there isn't a built-in function like there was with the other one. That's why we had to do this mess. All right. How's it coming over here? You got it figured out? Okay, this might have been a negative or whatever. Okay, good. Anything else before we start highlighting? Okay, now the fun part, at least for me, is here's what you highlight is that stuff is the stuff that you're going to change depending on what problem you're working on. Everything else, don't mess with this. Leave this stuff alone. Suppose we can even highlight this as yellow. Caution, caution, don't touch it. So do what you need to make sure that you don't mess with these. Once these are working, you want to leave them alone. Treat them like gold. Be careful with them. Or treat them like crystal? I don't know. Well, okay. Let's take a look at it. Oh, any other issues before we blow ahead? I know I'm looking at the clock thinking, oh, I need 5 minutes. Yes. Lower confidence limit is the same as the other one. It's just the middle minus the margin of error. So middle minus, and then this is the middle plus the margin of error. It is. P hat is the middle because that's the, think of that as that's the proportion from the sample. So that's like where the, so you're taking the sample proportion and you're like, okay, that's what I got from my sample. And then I've got the margin of error that says go this far on either side. And that gives me this as my confidence interval. All right, anything else? We're doing good because we have time for at least one example. Okay, let's do one example and then we can always loop back if we need to. So let's see, which one of these is more interesting? That's boring, that's boring. These are all boring. Well, we'll do a boring one, I guess. Yeah, whatever. It's just the way it is. Okay, so practice. Let me go back here. So I don't have, I should have had something from the survey that was qualitative, but I didn't get that together apparently. There are some survey questions that were qualitative, like I think there was like, what kind of pets do you have? I could have used that, but here, this is boring, but it'll work. So let's say that after a town mayoral election, researchers conducted exit polls, and there were 6,854 respondents, and 348 of them said that they had voted for a write-in candidate, and I want the 95% confidence interval. Oh, I should have done this with the last one, but I didn't. Let us pick some random people to help me out. So Trinity, what, let's see, we need 3 things. Don't worry, I'll give you a minute to compose yourself. I need N, I need X, and I need alpha. Okay, so Trinity, which of those do you want to do? N, X, or alpha? Okay, what is alpha for this problem? Very good. So you're saying, look at this, 95% confidence interval, 1 minus 95% is indeed 0.05. Good job. Okay, let's get another volunteer. Next person. So Will, which one of those do you want to do, N or X? Which one, what number is N? Yeah, the big number, 6854. Very good, thank you so much. And then Joshua, do you know what X is? 348. Those are the ones who said yes. So very good, 348. So let's go back to our spreadsheet here and use those three. And I know you're not going to be able to see, but oh well. So there it is. Well, you can kind of see if I move this around. Oh, I can. Hold on a minute. What if I do this? I'll pull this down just a bit. Okay, that kind of works. Okay, so alpha. So on your spreadsheet, we're only going to mess with the stuff in green, 0.05, very good. X is 348, and then N is 6854. Good job. Look at that. I've got all the stuff typed in, and you should get exactly this. So double check that when you type in these numbers, you also get those numbers out of this. I'll give you a minute, and then I need to type up the actual sentence, because the quiz on Friday, you're going to have to interpret this stuff. You're going to be like, well, how do I do this without Excel? You'll see. It'll be fine. You'll have to interpret this, and you'll have to write a sentence for me. But the sentence is always going to be the same. Well, almost always. But let me make sure numbers. Anyone stuck on the numbers? You got something, Will? Which line? 5 and 6. Okay, so this one, standard error. Yeah, that one's the most important. Well, actually, Z is probably 5. Yeah, 5 is also important, because those are the ones that are the hardest. So you got that? Oh, you're going to take a picture. It's also available on the video we're recording. So if you ever watch the video when we're doing this, you just fast forward to where you need it, and then make sure you're at like high def, because if it looks pixelated, it'll be hard to read. So yeah, you don't have to watch the whole video, just fast forward to where you need it. And then here's Z. You said this one as well. Whoops. Let me do that. That one's the norm. That tells you how many standard deviations. Okay, let's get this sentence written. I can go back, but I want to make sure we get a sentence. Normally, I wouldn't write the sentence on my gold web spreadsheet, but I'm just going to do it here. That I am 95% confident that the true, now, so that you've got your confidence level. That was one of the blanks. Now, here's where we need to actually specify what it is that we're working on here. And so here, let's see if I can do this without losing my place. What are we measuring? We are measuring the proportion of voters who chose a write-in candidate. Okay, so let's go back here and insert that the true proportion of all voters who chose a write-in candidate is between, let's see, how am I going to write this? I could write it like that, but that's kind of ugly, isn't it? I'm okay with you using a decimal, but it's kind of cool if you just change it to a percent, like 4.6% and 5.6%. Isn't that what we have here if I round? So this is 0.0455. Rounded, that's 4.55%, 4.6%, and this is 5.6%. So let's go with that. It looks better. So there's my sentence. And like I said, on the quiz next time, that's the thing that you want to really focus on, even though Newton doesn't really, it has something like that, but it's not as good as mine. So we'll practice that and on the quiz next time. We're all done. I'm going to stop the recording if you want to come chat. Otherwise, have a great day, and we'll see you on Friday.